Constant grid bias is analogous to constant gate bias in an FET, and you might like to review our videos about that before listening to this one. You can design triode amplifiers using similar rules of thumb to those that we used for FETs. But because of the coupling between the anode voltage and anode current, you can get much more insight into a design by sketching the load line. See video 69 if you've forgotten what this is. Sketch the load line on the characteristic graph of your triode as shown on the screen. Place a line nicely in the middle of the graph and away from any potential maxima, like the maximum allowed voltage or maximum allowed power dissipation. The amplifier that we're going to produce will look like that shown on the screen. The anode resistor, big RA, is given by the voltage supply divided by the maximum anode current, which in the case that we've shown in the graph is 200 divided by 1.5 milliamps is equal to 200 kiloohms. To bias the device correctly, we need to put -2 volts onto the grid. This will put us in the middle of the load line, and we do this through a large resistor RG. This has exactly the same function as the equivalent resistor in an FET amplifier, and in a small signal amplifier, 1 megohm is a common choice. As you can see, the amplifier works on more or less exactly the same principle as a constant gate bias FET amplifier. The DC blocking capacitors are chosen in the same way as in other amplifiers, in other words, to have a low reactance at the frequency of interest.